Okay. This one, lay your thumb along the wire, and it's going to the right. So my fingers, which is the magnetic field, will be coming out of the board on the top into the board on the bottom. Good?
Yeah.
Question 2 says, talk to me about the strength of the magnetic field. The strength follows, and we didn't talk about this yesterday, but follows an inverse square law. So that means the closer it is, the stronger it is. That should not have been a big surprise. However, if B is half the distance from the wire to A, how much less magnetic field would A feel?
4.
4 times less is correct. Good. Y'all heard that they shut down Palisades, right?
What?
Oh, you didn't hear that?
No. I'm going to have so much less energy in my house now.
I guess there were 80 gallons of radioactive water. So there was a radiation leak, but it was into one of the pools. It has not reached, as far as the reports have said, it has not reached beyond like acceptable environmental limits.
Today?
I think they may have shut it down yesterday.
Wait, so it's completely shut down forever? Or
No, just until they get the radiation under control. But the point is, we're pretty far from Palisades here. Keep going south if it gets worse. Because every time you double the distance, what do you do to the radiation? Cut it 4 times, correct. Inverse square law, okay? All right. Now let's try the following. If I have because you're going to need to know this for a little bit later. If I have a current carrying wire, draw that, and then I want you to do your best to draw a 3-dimensional representation of the magnetic field that surrounds that wire. What would you get for the magnetic field that surrounds that wire? Drawing, I know, that can be a challenge. It's the right hand, yes. Don't use your left hand. That's really pretty, Justin. And then compare it with somebody else that's sitting next to you and see if you got the same thing.
Did you describe this?
I guess, yeah.
Justin?
Wasn't me.
Oh, I can do that?
All right, let's see if you got the same thing.
Yeah, you go.
That's what it should look like.
I put 10 of those, though.
Now my question for you is, be specific. So at different parts on the circle, I want you to tell me the direction that the magnetic field is pointing, and it would be tangent to that circle. So in the plane of the board, to the left of the wire, so right here at that spot, which way is the magnetic field pointing?
Towards us.
Towards you is correct. How would you draw that?
Dot.
Good. Okay. How about on the other side? An X. Very good. How about right exactly in front of the wire?
A line.
Yep, it is a horizontal line. Which way? To the right is correct. And then right behind. To the left. Okay? Yes, that was funny to Mr. Hendricks. All right, so that is absolutely correct. Well done. We're going to be using that in a couple of minutes with existing magnetic fields, and then it gets really complicated. So before we do that, I don't think I talked much to you about the Earth's magnetic field yesterday, correct? All right, the Earth's magnetic field, scientists believe, it's kind of hard to experiment because we can't isolate this variable, but they believe it is due to magma flowing under the Earth's crust, and that moving iron causes the Earth to have a magnetic field which protects us from cosmic radiation. So that's really, really good. If I were to draw a picture, it would look something like...
Yeah, maybe it would be aliens.
You're not giving me a choice. Come on.
We would have adapted to it. I was like,
Well, yeah, if we were still around, we would have adapted to it by now. You're right.
Let's see.
So if that's the Earth, The Earth's magnetic field will look something like that. Let's see. Go like this.
It's the same as the outside of the Earth. They've never gone down far enough to get to that inner level, which is a parallel dimension. They think that the dimensions reacting with each other causes a magnetic field.
It's so cool.
All right, here's my question.
What you say?
Does anybody notice a problem with those arrows?
Yes.
What's the problem?
The wrong way.
They're all backwards, Justin said.
Yeah, because the North Pole's the South Pole.
Because what's the rule?
Oh, but look out.
No? Good guess. Out of the north into the south, out of the north into the south, out of the north into the south would mean that in northern Canada there's a South Pole.
No.
And the answer is yes. Yes, indeed, that is the case. Because we have decided that the North Pole on a compass will point north. But it has to point toward a what? A South Pole. That's correct. So I want you to notice a couple things geographically here. This is the North Pole, where Santa lives. Okay? In northern Canada. In whose
In that
world?
That world right there.
Is that beyond the wall?
In northern Canada, that's where the North Magnetic Pole is, which is actually the South Pole of a magnet. And so if you were to look at this in terms of alignment compared to Michigan, just seeing if this is something they could see on the video. So there's the North Pole, the North Magnetic Pole, there's the North Pole, and there's Michigan. So let's follow a line through northern Canada all the way to... So how are we doing if our compasses are pointing toward the North Magnetic Pole here in Michigan?
Pretty good.
Pretty good. Pretty much in alignment with true north, which is the North Pole. But what if I was using a compass and I was in Greenland right here? Which way would that compass point? West. Because the pole that would attract the North Pole of your compass is due west. If you're standing on the North Pole, which way will your compass point? South. Right.
Relative to...
Why do these compasses have bizarre sound effects? That's what I want to know.
So what would happen if you were standing directly on the south?
Excellent question. What would happen if you're right there? What would happen to your compass? No. It would just get pegged. It would just go down. No.
Is this place like marked off?
No. Well, you could visit it. It's a region. It's not necessarily like a pinpoint spot.
Oh, it has to be a pinpoint spot.
It's not.
It has to be.
Oh, okay. And it moves, by the way.
What?
It moves.
The crust.
Yes. So the stuff in red on the board is good stuff for notes because it is likely that those will be questions, multiple choice concept questions. So difference between true north, magnetic north, and something called magnetic declination. So true north, that's where Santa lives, that's the North Pole.
Can I visit that?
Yes, go ahead.
Mark is a
specific point.
Yes.
So then why can't the magnetic be a specific
Because it moves, my friend.
point? But it's a pole.
It's not like an actual pole.
Like, it's saying it's a
It's
pole.
made of aluminium. I saw it.
Don't say the South Pole. Say
Magnetic
South
north
Pole.
is in northern Canada. It shifts every decade or so, and it's the south pole of a magnet. Now, when I say it shifts every decade or so, that means that we actually, for those of us that are still into orienteering, which it's becoming more and more rare, orienteering is like the actual sport of using a compass to navigate out in the woods. Yes, it is a competitive sport. You can be a nerd in anything.
I've actually done that.
Yeah. Yes. So it's a way to use a compass to be able to navigate. Why is it that it's becoming less and less popular?
Because there's GPS.
Right, because we have GPS. Of course, there's GPS nerds too.
What?
Is this recording right now?